So in that way, you're not going to miss anything. Sorry. All these tabs. Okay. Okay, let's first have a look at it that homework and then see that what we're supposed to do on the homework. Homework, let's say that here. So mainly here that what we're trying to do over here, we are trying to build up some models, few models. That's all they were. We don't have to stick to the way that they have explained over here. You can build up some few models based on what you have learned, like a one-way MANOVA, two-way MANOVA, like that. And then when you do that one, just simply that get the data, and then whatever the variables that you are interested on, categorical or continuous. So on the other hand, what factors that you really want to work on with, and plus the variable factors and the groups. And then you can pick and choose of your own ones, and then come up with a descriptive analysis, and then talk about their data quality same way that we had in that homework one. And then eventually we're going to do the multivariate analysis. They perform the multivariate analysis using the either the proc GLM or proc mix if it's a mixed model like that. Okay. That's all. See, here they were giving like a rough idea that if in order to set up something, but we can have a look at it, our own things, and then move forward. Okay, let's look at that what I have done. Okay, it's not necessary that to be done by yourself, but it's okay that if you're going to go ahead and do the same thing, that's okay, that's fine. We get the data. What I did was that I just get some few data that might gonna be helpful for me to build up a certain variable called sedentary. I'm trying to build up that this variable. It's like a group. I'm trying to make it a group, sedentary. See? So in order to do that one, whatever the variable that we have in that huge data set, what I did was that I just got few of them. See, few of them that is related to sedentary. See, these are the ones that like for that one, I got this one. See, AD39, which is average length of the walk for transportation. AD41, number of time walk at least 10 minutes for leisure past 7 days. And then I get AE27A, AE27 time per day, moderate physical activity. And then I get AE25. See, days, number of days did rigorous physical activity. When the rigorous activity being involved, with that one that we can make sure that whether this person is actively involved with the physical activity for like a pretty much every day like that. That's why I got the max of that one. And then if it is 0, if even for the max is 0, then I call that one sedentary. Sedentary means like a label, that category being labeled by 1. If it is sedentary is 1, then its counterpart should be active. Active should be 0. Okay, so there are two. It's a categorical. I created a categorical or group variable. Okay? I created a group variable. See? Like that. See? So then, as usual, that what I did was that I just got my data, and then all the data, some places where that negative values being replaced by this one, the dot, and I did the same thing. Then I categorize the income. I got another categorical data because I need some groups. In our case, it's MANOVA is all about the groups. Okay, it's a counterpart of analysis of variance. ANOVA you have done in the previous classes. That this one, instead of working on one response variable, we're going to work on several response variables. But I need that for the x-axis, for the independent regressive independent variable, I need a group variable. So that's why I group this one. See, I group the income. AK40, AK22 underscore P is nothing but household total income. See, before. See? That's the one. See? So I label that one 0, 1. If it is less than 26,000, low, less than 51,000, middle, or mid income or something like that. 15,000, just simply 2, else, okay. If this is not that one, in between, then 51 to this one, see, middle, see. So 15,000, 150,000 more than that one, highlight that. See, I have a category. So I prepare two variables. So this one is sedentary, the other one is income. In addition to that one, there's a very easy one. What is that? The gender. Gender over here too. Sorry. Gender is that variable. See, SRSEX, gender. So once I get that one, see, I prepared all these. See, up to this one, let's run this one up to here. See? So that if you go, you can see that we added the new variables. This variable should be there. Okay. So then income variable, you can check whether that I call that one test my new data set. The very beginning, it's called the adult 2009. See, data out. It's in this folder. It's in this library. Then see, I'm going to go ahead and check that one. Okay. See, frequency table for sedentary as well as for income. See, there are all the descriptive statistics are displayed over here. This one 0 and 1. You know, 1 mean sedentary, 0 means active. Here low, none, 2. Their frequencies, their percentages, cumulative frequency, everything. You can see that one. It's properly that structured. And I don't have to, I went to the income. Sorry, that one. Sorry. This one, you don't need this one. Okay, this one. That's the same thing. We saw that already. See, already you saw that. You don't need to worry about either this already been done that one. We don't need this one. Okay, good. See. Then I prepared another variable. See, look at this variable. Everything that related to that mental situation, that kind of that all that related to the mentality, I put into the one place. See, I got the average of all these. Distress 12, 13. See, likely has a psychological disorder in the last year, likely has a psychological distress in the past month, and if 63, feel nervous first month, 65, 69, 65, see, feel restless like that, see, 69, see, 69, 70, 71, 72, whatever the variable that you feel like that gonna go together, that you can do like that, or you can keep it separately. Doesn't matter. It's not a big deal. But since we have so many variables, I think we have almost like 147 variable, I think, if I write. Let me see how many variables we have.
So you're saying we can pick whatever we want?
Whatever you want that, and then make a nice that eventually what we're going to have, that we really need to like run multivariate 2 groups 1, 3 groups 1, which is in which that we are using MANOVA, and the 2-way MANOVA, 1-way MANOVA, 2-way MANOVA. That's it. We're not going to go to 3-way MANOVA. It's easy when you know one that. But the theory behind that one, I did in large scale. In your notes, you can see last 2 days I discussed about that one in a massively. So you don't have to worry about that theory behind that one at all, because they were very consistent with what we are doing right now. When we do the printout, you have like a doubt where this coming from. You can go to that, refer to the notes and have a look at it, and then that place, and then you can even do by hand. See, so many things that very useful, that the notes that with the it's almost like a 80-90 pages, and then but you can get a clear idea what's going on behind that one. This part easy here, this part easy, but the build up the knowledge to what's going on is the key part that we are working over here. Okay, because it involves so many theoretical aspects. But anyhow, I'm building up my variable. This is a variable. This is something, one of the variables that I got the average of all these. And then I call that one data, man3, see, set test data, and then from that one, I got that one. Okay, so already inside this one. Okay. So then I straight go to B and then build up 3, whatever I really need. That's it. And body mass index, I'm interested in body mass index as well. Then this is my first the task. I'm gonna go ahead and run one factor. What is my factor? Sedentary. Sedentary would be my factor. It has a 2 groups, sedentary and active. See, 1 and 0, 2 groups. I'm gonna compare and see these 2. See, I'm going to compare these 2. I'm not comparing just simply those 2. I need the variable to be compared. I'm going to see what's going to happen to the mental, this mental variable and BMI, body mass index, so when people be inactive and not be inactive. See, being active and not being active, what's going to happen to the mental situation? What's going to happen to the body mass index? That's the kind of a discussion we are building now. But I'm not going to go ahead and do these 2 variables separately. That's not our purpose. I'm going to try to do these both variables at the same time in these 2 groups. That theory behind that one, I already did that, and I want to get back to that one anymore. See, sedentary and active, see, 2 groups, and then these 2 will be tackled at the same time. But in one univariate case, within these 2 groups, for this particular factor means which is going to be on the x-axis. That's a x variable, independent variable. This is another way we call the independent variable. The independent variable is categorical. Independent variable is categorical. And the dependent variable is what? First, dependent variable is continuous. But on the other hand, the independent variable is continuous, and then y variable is continuous. You do the regression. That part different. Can we do the multivariate regression? Yes. Can we explain the multivariate regression through multivariate ANOVA? Yes. And vice versa? Yes. So we can expand our knowledge in that, that any direction. Everything come to one place. See, one way ANOVA. One way means you have only one factor. One factor means one independent variable. It has a 2 groups because it's categorical. See, it's categorical. 2 groups, sedentary and active. And then I want to see within this group, by being sedentary and by being active, how it's going to affect our mental and BMI. See, I tackle both at the same time. See, this is my class. Sedentary would be my class. Class has two groups. Sorry, I'm sorry. Class, even though this calls a class, that is the group, that is the factor which has a classes. Okay, 2 classes, 2 groups. Either you can call the class, you can call the group, you can call the strata, levels, anything that you want to call that one, you can call that. And this is the model. Excuse me, these are the 2 variables. This is it's a group variable. And you're going to look for what? You're going to run ANOVA. Let's see what's going to happen. Excuse me. You got a whole bunch of numbers. See? That's it. You get a whole bunch of numbers. But our question is, with these all the numbers, can we what we gonna do with these numbers? That's why we need the theory. Theory we already did now. As of now, it's already done. Now we systematically built up that our discussion. See, we did this one. I ran this one. I want to know whether is there any difference between in the mental in these 2 groups. Are the averages the same or not? So does with this one, BMIP. Can I think about those 2 at the same time? I want to see that the average mental and average BMI would be the same for sedentary and active. How could we gonna write this down? How could we gonna write this down? So that's the part very important. That the writing part. This is the programming part. Theory part separated. As I showed you the matrix explanation. using the matrices, how this can be done. I showed you that how to use in the classical way, like the regular calculations. That one you saw that one. I showed everything in the graphically. You showed that one too. Now this is programming part. And then final part would be the discussion. So this is my first attempt. First attempt would be like this. I'm going to go ahead and build up the discussion. Okay. This would be my discussion. Let's look at the discussion. Okay. Okay, this related to that particular problem. This is my hypothesis should be built up. Okay, multivariate hypothesis. You're gonna say there are no mean differences. This is H0 multivariate. There are no mean differences between active and sedentary groups when they are simultaneously compared on mental and BMIP at the same time. Same time. Same time. See? Same time. Either you can write in plain English, see, like this. Or same thing can be expressed in a mathematical notation. H0 is nothing but the vector, average vector for the active one, I put A for the active, equals to mu. Mu for the averages for both are already included over there. And of the sedentary. That's the same as, see, that's the vector, column vector. Mu of whose mu? See, this one, mental of the active group versus mental of the sedentary group, see, and mental of BMI, see, comma A, mu, BMI. These are not vectors, these are numbers. Let's say 5, 6, 7, 8, like that, something like that. Something we don't know in population setting, we're gonna know that whether they were the same. And against its counterpart. Counterpart would be what? They were not equals. They were not equals. You know that one, not equals. So you're gonna write that one. See, you're gonna write that. Those are that. Now you ran this program. Then later on, this one a little bit. Write this down one more time for you to see clearly. Where's the exit? Okay, let's get this now. So I'm gonna go. So this is what I'm talking about. See, this is I'm talking about. See,
Professor, is this the same thing from that we were doing yesterday, or this is a continuation?
there's a continuation because these are I'm giving you the answers for the homework
Okay,
right now on homework. Okay.
okay,
This is a continuation, as you said, it's a continuation of our discussion, but I'm straight go to I'm on homework. See, homework 3. Okay. Homework 3.
got you.
Okay, then I got the data, which is data from that huge data set, and from that one I built up some 2 groups, the categorical variables. One is sedentary with the 2 classes, 2 groups, and the other one is income with the 4 groups. And in addition to that one, I'm interested in another variable I built up by taking the mean, and those 2, mean and BMI, body mass index, already available. It's a continuous. And those 2 variables, averages, are they the same? I'm sorry. Are they the same in this sedentary? Sedentary means in 2 levels, whether being active and not being active, are they the same? See, are both the same? BMI, body mass index, going to be same, being active and not active. So if it is the same, that what's the point of having been active like that? Would that the exercise going to be helpful you to that change the body mass index? Would that exercise is going to help you to that change that mental this index, which is I already built up by averaging this one. Okay, so I'm here now. I'm here.
Okay, gotcha.
Okay. So for that one, since I ran this one, I ran that one, then I got the result sheet. I don't know what to do. That's why I'm trying to build up now that I know what to do, but what I'm trying to say that you were thinking, okay, is that the right one? I want to look at it. I'm sorry. This one, okay. See, this I have so many tables, Now we have to figure out how to get that resource being interpreted at the end of it. That's the discussion now I'm building up over here. So main thing, as I said in that this one, see, this is my null hypothesis. There are no mean differences between active and sedentary groups when they are simultaneously compared on mental and BMI variables. So the same thing I'm going to show you in this one. That's same thing that we discussed yesterday too, but I'm going to go back to this one more time. Why it's not right. So this is my, these are my factor. Or some another way I can say the categorical variable. Categorical variable.
There's a pop-up window.
Oh, I'm sorry. I'm sorry. Okay, pops up. Okay. Okay, and the way that we can say the independent variable. Independent variable. Okay. Independent variable. See, for some people they call the regressor variable. If you want, you can say the regressor. Doesn't matter. It's related to regression as well. Explanatory variable. See? Explanatory variable, but it has a level. Okay. Categorical. That one is categorical. See, level, 2 levels. What's the name of that one? I used to call that one sedentary. Under the sedentary, again, you're going to call this one active. I'm going to call this one active. Active is 0. This is sedentary. Then you have Y variable. Y. Y is your response. Or dependent variable. Dependent variable. Or regressed variable. Regressed. Well, any name. Okay. It's nothing but you have a not 1 here. You have a 2. See, you have a BMI and you have a mental. 2 variable you tackle. In a regular setting, in a univariate setting, you tackle 1. I'm tackle 2. 2 or more than 2, doesn't matter. You give 100 of them for the response variable, I can tackle. You can tackle now. So we want to see whether those two would be same. See, this is my H0. H0 I wrote in plain English. Now I'm going to write this one. See, mu of the active group is same as the average of the whose average? Not the group's average, average of the mental and BMI. Okay, see this for the sedentary group versus its counterpart HA. HA would be HA would be mu A vector not equals to mu S vector. That is equivalently you can write mu in this one of that guy's what? Mental. I'm going to write with M. And mu of BMI, comma A. See, those two, same thing. Those two, same thing. It's not clear. You go to that group, we're going to talk about this variable, M, mental variable, comma A. Its average, and BMI, comma A equals to mu of mental coming from sedentary group, mu of BMI coming from sedentary group. See, that's the same thing.
So just for clarification, we're comparing the means of the two variables amongst the two groups.
Exactly.
Okay.
You got the point. If it is we used to do this on one variable being compared, but in this discussion in multivariate, because that's the most general case, multivariate is the key part. You have to know the multivariate because that's why we are using matrices. You are comparing two variables in two groups. Exactly. That's right. Can we do this one for the 3 variables? Yes. Can we do this one for three groups? Yes, that's one. That one I'm gonna come to later on. That's called ANOVA. It's called MANOVA because of multivariate because of that. Can you compare these two groups? Yes. Versus its counterpart. Versus its counterpart means the same thing. See, same thing not equals to this one. HA. It's another way to see mu of mental of the active group, mu of the BMI, comma of the active group, this one mu of the average of the mental of the sedentary group, this one mu of the BMI of the sedentary group. See? Now I have to check that one. In order to check that one, what is the what number? What we gonna do? Where's my test statistic? Can you remember situation like this? What test statistics we are using? Multivariate two groups. Multivariate two groups. Okay. When you have a multivariate two groups, which test we have to use? You did see. We did several things.
Yeah, so yeah, the t-value,
T
t-test.
value. We use the t value. No, t value we use for the univariate case. It's not univariate. See? Univariate t. It has been t squared to get the t. Even for univariate case, you can use the t or t squared or f. That's multivariate. That this is there are no two groups. It's a one group. We keep going. We did the example, and then I'm gonna go to two groups. See, one factor, two groups. See, univariate case. See, like that. Its counterpart. Let's go to cases. Blah blah blah. Univariate. There you go. See, active group, non-active group. Active group, sedentary group. See. That's exactly this one. In order to run this one, what do you need? You need the t squared. You need the f. This guy. I need this guy. I need that table. Are we going to do this by hand? No, we don't. We don't. We don't. We don't. We don't do anything by hand. See? See? This one, look at the same kind of a question. See? That's the same thing, same kind of a between these two variables, between two groups being compared. I did by hand. See? I did by hand, built up everything there by hand. And eventually, you really need some who would be the most important parameter that taken into account. The Wilks lambda. Where is he? Where is my Wilks lambda in my printout? Let's go ahead and look for the Wilks lambda in our printout. See? In our printout. Wilks lambda. Sorry. See, go to research. All the way down here. See? If you want, you can get the Wilks lambda. If you want, you can get the F related to Wilks lambda. If you want, you can get the P value related to Wilks lambda. See, who will be utilized? You can utilize either this guy and compare it with the critical value of F, or you can get the P value and by looking at the P value and see whether it can be compared with what that the compared to the level of significance. See, level of significance. See, like in this example. See, I go here and go further down. See how they are related to P, how they Wilks lambda limit related to F. Whether you don't, Wilks lambda is not enough. You have to go to the distribution. Wilks doesn't have a distribution. Wilks is connected to F through this all the formulas. See, different situation. Different situation doesn't matter. Whatever the situation, it's already been taken care of now. See, hotline, all these numbers, you can see. Look at here. Everything now connected. See? 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 Like this. See? You can go to either. See? I'm sorry, not that one. That will slam that related to that one. See here, this one. See? They all pretty much have the same, see? Same F value, same degrees of freedom, numerator and denominator. How could we know 2 and 6 in that case? Same way, how could we know here that in this our example, why this my sorry, see, why by that the numerator degrees of freedom is 2 and the denominator degrees of freedom is this one because it's based on the theory. See? You might be thinking the 47,328. This one numerator degrees of freedom. Where are they? Let's go to that one. Let's go to that one and have a look at it. Degrees of freedom. Here. See? Here. Here. See? T. See? Degrees of freedom is nothing but 2 P equals 2 because the P stands for what? Number of variables. What are the two variables we are dealing with here? BMI and mental 2. And degrees of freedom for the denominator for the F distribution is nothing but the total. This one is for the first group, group 1's number of elements in group 1. This is a number of elements in group 2. Together, this is a total number of observations. In our case, we have the 47,400. We have 47,000. Sorry. We have 47,331. No, is that right? 47,338. Is there any?
47,331, yeah.
331. See, 47,331. See, it's my total observation. 47. See, 47,331 minus P is 2 and minus another one. That means you have to subtract 3. When you subtract 3 from 321, it's going to be, sorry, 331 is going to be 328. 328. See, that's the same thing. You see, 47,331 minus 2 minus 1. So you're not going to miss anything. The way that I did, you should not have a doubts on anything. If you carefully follow that note and then the printout over here, they are very consistent. Because I spent a lot of time to build up these notes. These notes you cannot find anywhere, one place. It's all scattered all over the place. And even the textbook, they don't have nothing. It's a very weird, nothing. These are, I spend a lot of time to build up these notes because it's important for you to, because you guys are master students, you're going to go for a PhD down the road and even for a go and work somewhere, do so many things. You need this knowledge. It's important. Very important. If it's a bachelor's student, I'm not going to go like this one, but I decided no, this has to be that delivered in this manner, in that way that whatever you want, you can filter out and then take to you, and then the rest you can keep for future reference, like that, like that. So anyhow, you're not gonna miss anything. That why they were like that. Now you know. Now Wilks lambda, how could you got that number that's gonna be displayed? It came through this whole discussion, W over this one. Those are we can calculate. You're not gonna calculate, but I did both that one. See, I did all by. I can handle this one that very easily. So I like to have a compare and contrast. Like you don't have to, okay, for that homework, don't do anything this one. Don't do this part. I don't need. You simply have to answer those, build up these 3 questions and then write up and then attach that SAS printout and then send to me. That's it. Okay. So when we go back to this one again, see this number. Even then we know how we got this number. We know how to get this number. We know how to get this number. We know how to get this number. You know how to get the p value. If you know the f value, you know how to get this p value. We had that broader discussion all the time. You can remember that. If you know. Yeah, see, if you know the critical value, see, if you know the p value, how to get the p value, we did that one too, at a certain point, okay, but you don't have to do specifically for that one. But what I'm trying to say, by looking at this one, now you know that then now we can build up the discussion. I'm gonna go back to this one again. See, I'm gonna continue this one, discussion. Okay. So since, see, see, since p-value for Wilks lambda is less than 0.005, we reject H naught. That means our test is significant. When the test is significant, we have to do, when a test is significant, what are you supposed to do? Then I mean, you have to do several things. That's called the post hoc. Post hoc means like right after that test is post hoc procedures. What are the post hoc procedures? In general, when the multivariate null hypothesis is rejected, several follow-up procedures can be used. These are the procedures you can do. Conduct a series of one-way ANOVA, not MANOVA, one-way ANOVA or for each variable. In our case, we have a two-variable Y variable, mental and then BMI. You're going to identify whether the group differences are present for a given dependent variable. For each dependent variable, can I run the ANOVA? Yes. Do we have that table already available? Yes. Yes. Or you're going to use some kind of procedure called the step-down analysis. Okay, requires that you establish an a priori ordering of the dependent. That method that we're not going to talk about here. There's another method called the multivariate multi-level modeling, MVMM. These three methods are the most important method. Out of that one, we are focusing on this one. Conduct a series of one-way ANOVA. Okay, when you do that one, okay, you're gonna do that one. Okay. Conduct a series of one-way ANOVA for each Y variable. Now, when you do if the group differences, now you're going to do the one-way ANOVA, that test. When you do that test, if it is rejected again, then you have to jump into another test. If the group differences are found for a given Y variable and a design includes that there are more groups, then the pair, see, if group differences are found, see, when you do this one-way ANOVA for each variable, you're going to say that you're going to reject H naught. Your test, that particular test, I mean like a test for each and every variable. In the very beginning, we did the overall variable for the both of them at the same time. But again, this the single that univariate one-way ANOVA is significant, then you're going to go ahead and do the multiple comparison. That multiple comparison you can do in two ways. Those are very famous to multiple comparison means you're going to compare two groups at a time. If you have more than two groups, you can compare two at a time. Okay, two at a time using the Tukey adjusted with the alpha adjusted. That means you're going to get that alpha divided by number of variables are available. Okay, this is not the Bonferroni. Bonferroni we do the different way. Bonferroni, you're going to see that how many pairs can be, how many comparisons are done. Let's say that you have 10 groups. Out of 10 groups, if you, let's say you have 5 groups, five groups. Then you're going to do the comparison at a 2 at a time. That means 5 choose 2. 5 choose 2 would be how much? 5 times 4 divided by 2 times 1, which is 10. Yeah, 10, which is 10 groups. Okay. So like that, you divide by that. Here, not like that. Here, you're going to divide by the number of variables in this one. See, if there are 5 variables, you divide by 5. Or you're going to do the Tukey without alpha adjustment by taking this one as it is. Okay. Can we get the Tukey? Yes. What the Tukey says. Tukey say that Tukey can be done. That one for multiple comparison. This is how they do the multiple comparison. Sorry for the pairwise differences for the Tukey. This is your that 2. You get only 2 at a time. Okay. We had a lot in the beginning. Let's say we have so many the groups. This one we have only 2 groups. Then we don't have to worry about this one. But anyhow, But I'm trying to say that if you have a several groups, see G many groups, you get 2 at a time. And the method one, you're gonna reject H naught. What is the H naught? H naught would be what? This one. These two the same. Averages are the same for that any two pairs. You get this value, and that should be more than the critical value coming from not the T. This is called the studentized range statistics. This is going to be available in some, you can go online and get it, or that even in the in this textbook at the back of the textbook at somewhere in the appendix is available. For alpha, you don't put alpha. Mean squared error, everything that you know mean squared error, you know n, you know capital N, you know capital N is Ni plus Nj because the two at a time, and this is two because the two variables. G, sorry, groups, number of groups, I'm sorry. Okay. This is G also, N minus G. Either this one greater than this one, you reject H naught, which H naught, this H naught. Okay. So I'm talking about the three tests, okay? In the beginning, you have a multivariate test. Later on, you have a univariate test. Then you have a that pair test. In this multivariate setting, you are always doing three tests if you have a more than two groups. But in my example, I have only two groups. You don't have to go that further. But at least you have to, that when you do the multivariate, when the multivariate is rejected, you definitely move on to the next one, see, single ones. That's what we are trying to do over here. See, since that multivariate one is rejected, see, null hypothesis is rejected, you got a single one. One way ANOVA for mental and BMI separately. Are they available? Okay, let's go ahead and look at our printout. Yes, they are available. Okay. Look at this one, the dependent variable. This is the ANOVA table for the dependent variable. This one, see, look at the p value. See, the p value for what? For this one is what? How do you write this one? How do you write that this one? If you write that, let's say that you want to write its null hypothesis, conjecture, how it looks like. This one you wrote this one. That's for the multivariate. See, that's for the multivariate. See, I'm gonna call this one multivariate. See, multivariate. See? Multivariate one you wrote either this way or this way. Multivariate. The multivariate one, multivariate H naught is rejected. Now you're gonna write what? Now you're gonna write for mental variable. You're gonna write what? What? Mu. Who's mu? See, mu of that guy. Sorry, mu of mental in the active group equals to mu of this one in mental in sedentary group. See, versus HA would be mu m of A not equals to mu of M but not sedentary group. That's for that one. See? For other variable, for BMI variable, I'm going to do this one separately. See? H naught mu of BMI comma A equals to mu mean of BMI of the sedentary group versus its counterpart mu BMI of active group not equals to mu BMI of sedentary group. See, those check. Can you check that one? You're going to check the p value for this one. P value less than 0.001. Reject H naught. See, reject H naught. See? And this one p value for here. P value less than 0.001. That's the conclusion. Reject this H naught now. The second one. This H naught I'm going to call the univariate. Univariate. See, univariate. So separately I do that. Those are rejected too. Those are rejected too. That means both of variables are significant. Both of variables are very significantly that contribute. No, that means they both contribute to the overall difference. Both variables are significantly contribute to the difference in the the multivariate test that we carried out over here. We say it's significant. Significant means you reject H0, this H0, multivariate H0 by looking at Wilks lambda. For this one, you use the Wilks lambda. P values from the Wilks lambda. P value, see, P value of Wilks lambda. So Wilks lambda, this one less than 0.001. We reject that H0. Reject H0 multivariate here univariate H0. You reject univariate is also univariate separately used. That means, see, both variables are significant for the overall differences in averages or average differences. That's how we can do. But if you have more than two groups, you go further down. That's what I'm trying to say here. If you have more than two groups, let's say three groups, then you have to do two at a time. Three choose one. Three choose one is three. Three, one and two, one and three, two and three, like that one, and then make a conclusion at the end of it. So it's very, very, very nicely, very well structured. The setup very well structured. Okay.
So we do comparisons between each of the possible combinations.
Exactly, each of the possible combination, each possible groups within that one. Let's say income. Income has a 4 groups. If you have a 4 groups, you cannot stop here. You're going to do the separately for the 0 group, 1 group. That means a low income group, middle income group, high income group, sorry, upper income group and high income group. That's not enough. You have to make sure you do the ANOVA for that one for that one has been done like this way for those groups. For those two variables, you have two variables, but you have done this one equals to another one, equals to not only this one, like a 0, 1, 0, 1, 2, 3 groups. Okay, but you have a two variables. Can we expand a variable as well? Yes. Many variables? Yes, we can add as many as you want. But my bottom line, you go to the multivariate test by looking at the Wilks lambda. We're not going to do anything by hand. I showed you everything very rigorously. In this class, are you never going to get a chance to learn this one even anywhere? Because very rigorously, I did everything here in this summary. This has been summarized everything. So you can, not going to miss anything. And but on the hand, with this printout, we have everything already. They were very consistent if you go ahead and get it done by the hand. See? And for our discussion, see, ANOVA table and MANOVA table. See? This is MANOVA table for multivariate testing. These are the ANOVA table for each and every variable. Okay, variable, not the groups. Okay. Groups are independent variable. Groups are coming from independent variable. I'm not interested in independent variable. I'm interested in the dependent variable. Okay, dependent variable. I'm interested in these two, not these ones. Within these groups, and this one, can this be continuous? No, no, no. Can this be anything on this one continuous? No. We use a regression then. We cannot use this analysis of variance. We go to the regression. Since we have a categorical data with the several groups, okay, at least two groups, then we're gonna do that one using the MANOVA, multivariate analysis of variance. And multivariate analysis of variance can be explained through the regression and vice versa. That's a different story. But we have to make sure that what we are doing very clearly. Okay, so we have all these necessary components to make the discussion at the end of the day. Okay. So
And so basically our discussion comes down to, in this case, we're rejecting the null hypothesis on each one of the factors based on
each
the,
one of the levels, I prefer to use the each one of the groups in the factor.
okay.
Okay.
And the base, and we can do that based on Wilkes lambda of the p-value less than 0.05, because we're going with a 95%.
Yeah, in the very beginning, that's the first test. You do that one. If it is significant, if it is not significant, you're not going to go any further.
Because if it's not significant, you're going to accept the null hypothesis.
Exactly. They both are the same. Then you come to the conclusion. That's the final conclusion. Final conclusion is done. You're done. You don't have to go any further. But in the most cases that, in the most cases, we are trying to get the null hypothesis rejected. Now we have a question. In order to get rejected, can we maneuver the alpha and the power of the test? Yes, but we don't do. The alpha is like the analogy for this one. It's like in a courthouse, that's the judge. Judge is the alpha. Okay. He has to make sure that when you're gonna make it that by looking at the evidence, by looking at the legal aspect and have a balance, and then he decide this person is found guilty, not guilty, or if that's the case, how much of that incarceration should be given to this person. He is the alpha. That one we cannot change in a way arbitrarily. That creates a big problem. Same thing in this statistical testing too. That's
So we
go ahead.
We have to decide on what that alpha level is going to be before we even start doing our work.
Moderately for a good testing, normally we're going to use the point, not actually 0.05, that 0.10, and in that way we can keep a nice power on the other side. You see that the higher the value of the alpha, the lower the value of power. Power has to be kept too. It's like a two sides of a seesaw that has been balanced on a fulcrum. So that's why we cannot, for the sake of that arbitrarily judge might gonna think, okay, go crazy and think, okay, they should go home or they should go to the jail forever, whatever. It's not even in the book like that. But that's the same way we can we do that one arbitrarily? We can, but we don't. we don't. Because it's gonna affect. It's gonna destroy the whole test at the end of the day.
We can do that if we want to make statistics say different things than what they say.
Exactly. That's why most people thinking in order to get, but most of the cases, look at that even in the courthouse, the null hypothesis one, the defendant is innocent. The defendant is innocent, but the government prosecutors and everybody try to get him guilty. That's their job. That's what they're trying to do. They try to reject H0 and say, no, he's not innocent. Like that. That's the same thing. So that's why that alpha, that this in this case, we tackle both variable at the same time. Very interesting, very easy, very convenient, the structure that because of in our day-to-day life that we're not going to tackle only one variable at the end of the day. Now later on when you exposed to that all this data analytics at the end of the day, you tackle so many variables at the same time. Then it will come to your head right away. Wow, we have a multivariate analysis we did. That should be the one that we have to utilize. That's the one. This is the key. In the very beginning, we just were laying down a foundation to move on to this one. This is the key part. Even that's why that all the program being that set up in using matrices. Anybody that who wants to be like a SAS developer or R developer or that Python developer, that they have to know this theory behind that one thoroughly. In that way, that otherwise, that's why those people get paid very high salaries at the end of the day, because they carry knowledge and the experience, and they spend a lot of time. Okay, they've been compensated mainly not for the skills, mainly for the time they have spent to build up that skill. Okay, then we did this one, we did that one in our discussion. See, I'm gonna little bit see. Since the test statistics, we conduct a series of one-way analysis for variable mental and health. Since p-value less than for the ANOVA for mental variable, we reject H0, which is there's no mean differences between active and sedentary groups for variable mental. See, there are no mean differences between active and sedentary. See, for mental variable. See, that means there's nothing gonna, whether being active or being sedentary, there's no big difference. So what's the point of being active? People might think. Well, then what's the point of being sedentary? Like that on the other hand. And that is this one, if you want to write mathematically or in plain English, either way is fine. And similar fashion, you can get this done for even for the other variable, BMIP. You saw that one too. See, then we're gonna stop this discussion. That's it. That's all you have to write down. You cannot go beyond that. And that means that both variables are, as I said, both variables are significant for the overall differences, overall average mean differences at the end of the day. Both are actively ignored. Because in multivariate, we're gonna see that which variable gonna be significantly contribute to the overall changes. In univariate case, we're gonna see that which group gonna significant like that. Okay, that's why we're not gonna stop that multivariate one. We go to univariate, and that's the reason the univariate ANOVA tables are displayed here. There's a reason for that one. See, so we don't have to worry about that one. Ahead of the time, they know what we need. Whatever we need, they have already built up. See, even by looking at this R squared, see, would that be a good fit? Those discussion, different discussions. See, R squared is the one that we looking into and see whether this is a good model or not. See, we talk about the models too. This model, rather than this model, can we go to the different model? Yes, then you change the model, because you see, look at this, how much that error being, see, how much error being explained by this much of massive error coming from the null empty model. They explain only this much of error. This model not good at all. See? Look at the R. R is what's the proportional reduction in error. Proportional reduction in error means this sum of squares model divided by sum of square total. You know.
So it's about 1.4% of the error has been described by.
Yeah. See.
Yeah.
See? This is nothing. Then can we go to a different kind of model? Yes. Can we go to the, instead of ANOVA model, can we go to the regression models? Different kind of model. Can we add the more variables? Can we add more levels? So many things that we have to take them into account at the end of the day. That's why you have to broaden your knowledge, because you cannot that just confined to only this discussion and thinking, oh wow, that okay, reject H0, we wrote that our conclusion we done. No, it's not what we are trying to do over here at this stage. We were saying even these numbers are very important at the end of the day. See? And then we had that, the other classes, I talk about the type 1, type 2, type 3, sum of squares, that broader discussion we built up all the time in the 605, 600, and even in that 625. Sometimes you might have taken with me or sometimes you might not, but anybody who have taught that one should have done all these in a detail. That's my understanding. But anyhow, that's that one. Okay, let's move on to something with the the 4-1, sorry. The same discussion, one way ANOVA, one factor, but I'm using 4 groups. I'm trying to use MANOVA now, see? Multivariate analysis of variance I'm going to use. I need the Tukey one too, see? As I put the Tukey. Who's Tukey? That income variable. I used only one, see? One categorical variable. See, you don't need this one. Sometimes, okay. So you have one factor, which is the income being factorized, because you might be thinking, well, how come? Yeah, we did that one over here. See, it's called income. In the beginning, it's called AK22 underscore P. That's the AK22 underscore P, household in total income. See, it has been recorded under this public use file. See, it has been now categorized. See, because of the category, they've been categorized. But I'm trying to tackle with respect to this one to see the same 2 variables. Okay, same 2 variables. So this time that we have that 4 levels for my independent variable. I have a 4 variables. See? I have a four levels. See? This is my X variable. X is nothing but income. Income is what kind of variable? Categorical. Categorical variable. We used to call this one cat variable. I have a here what? Y variable, response variable. There are two variables. One is mental. That one is quantitative variable, numerical variables. Can you remember? We used to call this one quant variable. This way, if you want this one qualitative variable, qualitative. The other one is BMI 2. It's also quant. Then you have variables 0, 1, 2, and 3. 0 means low. This means mid. This means upper. This means high. See? For this one, you're going to measure that, we'll see. For both variables at the same time. See, both variables readings, you're going to see. Take into account. Can we build up the model? Yes, we know the model. We know all discussion. We know how to build up even the ANOVA, MANOVA, all tables. That broader discussion we done. We know how to write the model. You're going to write the model for that observation. This observation, see, observation, you can say that vector y, both will be given I, given reading. See, I gonna go from where to where? Gonna go from 1, 2, all the way up to G. G is how many? 4. 4 groups. J. See, each group has how many? You don't know. That's why I put Ni. For a given Ni, when I equals 1, N1 would be how much? This one has an N1. This one has an N2. This one has an N3. This one has an N4. Right there. See? 4 groups. And then when you add these together, that's the total. Capital N. So you can write this way. I goes from 1 to G, which is 4 N9. That's the same thing. So that's the presenting. It's about that presenting you that all that material in a very nice way. At the end of the day, you have to do a thesis or project. Then you have to present your material in a nice way. You cannot simply put in a simple way. People don't like. They like rigor. You keep the rigor if you do like this. It's a graphical representation. There's a matrix setting. We already done. We're not going to go there. Let's run this one. Okay. Let's run this one. I'm going to say I need this one. I need the Tukey too, because as I said earlier, if by any chance when I run this, okay, let's write the our test H0. Let's write this multivariate test. Multivariate test. How do you write the multivariate test? I'm going to write mu of the first group, 0 group, mu of the first group, see, mu of the second group, mu of the third group, see, okay. It's not. Versus this HA would be what? At least.
The same thing and just not equal.
No. You cannot. That's a very heavy. If you put the not equal, it's a very extremely heavy test. Here we're gonna say we don't know, but we can say something very plain, like a very simply. At least 2 of them are different. At least 2 of them are different. Vector, okay? I'm talking about the vector. That means this guy not equal to this one, J, I, and J not the same. If it is I is 1, J cannot be 1. That's what I'm trying to say. It's being compared to the, if it is 0, you're going to say this one. And I and J both can take, see, not this I and J, okay? I'm using not the one on the top, okay? Don't get mixed up with that one, okay? Don't get mixed up with that one, okay? I'm going to use the different letters, okay? So you can see L and M, no, okay, L and M, this is L, this is M. L and M can take 0, 1, 2 and 3. At least two of them are different. At least two. Which two we don't know. That's why you have to move on to the Tukey. But there's no Tukey for the vector format. There's no Tukey for the vector format. This is in vector format, okay? Because I'm trying to tackle both variables at the same time. Equivalently, if I write this one, see? Okay. I'm gonna write H node. See? See? Then you can write, see? There are, okay, I write in plain English too. See, there are no mean differences among this one 0, which is low, 1, which is mid, 2, which is upper, and 3, which is high, groups when they are compared when they are simultaneously compared on mental and BMI. That's if you want to write in plain English. Or equivalently, you can say its counterpart, you know, you don't have to worry about that. That you see, they are at least two of them are not different. Okay, I already wrote that. That's right. Okay, so other one, you're gonna say the mu of which one? Mu of mental, the 0 group, mu of this one in BMI, the 0 group, equals to mu of mental of first group, mu of mental BMI, sorry, BMI in second group equals to mu of mental of the third group. Sorry, this one first group. Okay, first, second group, mu of BMI of the second group equals to average of mental for the third group, mu of the BMI of the third group. That's H naught. I wrote the H naught on this one. BMI in the first group. Okay, BMI in first group, BMI in 0 group, BMI in second group. Sorry, this one cannot see. Second group. This one in third group. See. This one in first group. This one in 0 group. And write this one in any of these ways. 3 ways. I wrote that one in 3 ways. Now, how do you get this done? This is related to what? This is related to the maneuver. In our notes, do we have that one? You keep going that one. After this example, see, yes, see, 3 or more group classes, see, 3 or more group class. How many groups we have? G many groups. If that's the case, see, that's the model. We wrote the model. We can remember for univariate case. We're not interested in univariate case. Let's go to the multivariate case. See, as I said, for the mu1, mu2, mu-g, in our case, we have only 4 groups: mu0, mu1, mu2, mu3, mu4. Within that one, we have within the vector, we have our own variables. See, equivalently, that one we built up all the pieces again. You get the Wilks lambda. See, Wilks lambda. Okay. Do we have a Wilks lambda? That's the same example. See? Yeah, this example, same thing like that. We can get it done by hand. In this example, I have done by hand, and then I check that one. See, let's go ahead and run this one, and then see that what we have. So, and then at the same time 2 key too, because as I said that when that one is not cannot be done, then you have to jump into the 2 key. Okay, let's go ahead and run this one. Let's go to the overall one, multivariate one. Wilks lambda. See, you reject H naught. See, multivariate one, you reject multivariate. When you reject multivariate, what's the next step? You're gonna do the same test, ANOVA test for each and every variable. Do we have those tables? Yes. See, for the mental one we have, for the BMI index you have. See, we have. See, we have both of them. Since then you can simply say this is for the multivariate. See, I'm gonna put multi. See, multi. See, one. Then since multi we reject H naught, which reject H naught, multi H naught, we have to do, see, we're gonna reject since p value is less than, okay, you know how to write it. We have to perform univariate ANOVA for each variable. What are the variables? One is mental, the other one is BM. See, so that means I'm going to write for that. See, mental. See, for mental, if I write the ANOVA for mental, I'm going to write H naught uni1. This is uni1, okay, univariate one. How do you write? See, mu naught, mu1, mu2, mu3. No vectors anymore. See, versus its counterpart, at least 2 of them are different. That is, see, mu L, mu M, they're not the same. L and M are not the same, but LM and N can be assigned 0, 1, 2, and 3. Okay. Or plain English, you can say that for a mental, see, for a mental, those are not the same. See. So you can equivalently, you can write this one. See. You can write H naught for the univariate case. Okay. See, there are no mean differences among 0 is low, 1 which is mid, 2 which is upper, and 3 which is high. Groups for mental variable. For the mental variable. Or if you want, you can write like this. Okay, if you want, you can write like that's the same thing. HA, you know how to write HA. I'm mainly focused on H naught. Now, can we run that one? Yes, let's go ahead and look at our printout for that one. So for mental, again, see, less than 0. Let's go and do the BM. Both will be rejected. Now you cannot stop there. Now you have to go 2 key. You go 2 key, then you go to the pairwise comparison. Now you're gonna go ahead and do the pairwise comparison. Okay. Now you do the pairwise comparison. See? Since see? Separately, okay. Since see? means P value. So I'm sorry, I'm gonna say we reject H naught uni for mental and BMI. We have to perform pairwise. Now pairwise, 2 at a time, comparisons for those 2 variables. Oh, I'm sorry, I mean I write you didn't see that. Since we reject H naught uni for mental and BMI, we have to perform pairwise comparison for those 2 variables. How do you do the pairwise comparison? Pairwise comparison means Tukey comes here. Pairwise under the pairwise comparison, that Tukey 2 at a time. We're going to do 2 at a time in each group. See, 2 at a time. See, 2 at a time. Look at the two variables. I'm talking about for a given any variable, 2 groups. Okay, you have a 4 groups. You're not going to take the 4 groups that you consider. It's done. You consider the 4 groups same time and then check their result. You reject that. They don't have the same their averages are not the same for each and every group. Then you're going to compare that one 2 at a time within 2 groups. See within these 2 groups. How do they do that one? Tukey came up with something and he said you can get this value greater than this value. This value you can get it from a book. Mean square error already available in ANOVA table. In univariate ANOVA table, mean square error. I'm talking about this one. Let's say mental. You were thinking where is the mean square error? For the mental one, mean square error is nothing but this one. This part. For the mental one, mean squared error. See, mean squared error. See, it's already there. And n would be how much? N is number of observation feed 47,614. Is that right? How many? 46 n minus 1. Yeah, 46,089. No. Some are missing. Some missing data. Okay, you have to remember that one. That's okay. That, but at least, but whatever that they recorded over here, based on that one. See that n over there. See. This one within the 2 groups. Okay. This is sorry. Then with these 2, both are the same. Okay. Then both are the same. You can divide by n. They both have. If they were different, if they're different, okay, this can be utilized when they both groups have the same sample sizes. Okay. If not, let's see that if not, should be somewhere. Then you're going to use this. Then they when in my course, just not this one. This is for 2. This one. That's for two of them, not that. Okay, that's right. Oh no, that one. I think that's not right on the top. This part. Don't worry about this one. They were not same. That they were not same. Then you can use the t variable. See, not this one. Okay, not the 2. Not this one. This is not right. Okay. Oh no, I'm sorry. That this is that one or this method. They still this one is n. Okay, this one is still n. This one is still n. Still n. But there's another way to get this done. Either you're gonna use what q compare with this part p, and then check with that one. That's the same thing. Okay, that's the same thing. But anyhow, that two key that sorry that two key. If I'm sorry that if they were not same, only difference. Okay, they say that if they were, what's gonna happen that if they were, if the sample sizes are not different in our case, what's gonna happen? See here, see here is the part that see here instead here this one you can adjust. Okay, then I'm gonna say mean squared error divided by see this one n1 plus n2, not n1 plus n2. Sorry, 1 over n1. See, this one should be mean squared error. Mean squared error. This one like this. Okay, I'm gonna get this one and split it. Okay, like this. You have like this. You can see like that. I split that one. Okay, that part. Let's say how did you get that one? It's been like this way. Okay, mean squared error. This one 1 over n plus 1 over n, like that. It's been like that way. Later on, when you have added together, because for both have the same one, you had like this, see, mean squared error, see, mean squared error times square root times 2 over n. It's been like that. See? That 2 has been absorbed, this root 2, then I'm going to get this one, mean squared error, see, square root 2, 1 over square root 2. And that one I'm going to put here together and then keep the square root outside and get that square root 2 at that being absorbed inside this one. If they were not same, it should have been like this. That's what I'm trying to say. See? And since that, see, the root 2 is being multiplied by root 2, this has to be divided by root 2, see, like this. Is the formula for that one when they were not the same, but it doesn't matter. It's not a big deal for us. Why? Because we can get the two key comparison for both of them. Two key confidence interval I'm going to build up. Okay, comparison. In order to compare, you can get the confidence interval. That's good for the differences. Okay, so for the differences, I'm going to get the two key one. See. So that's why I put the two key over here. See, for the income data, for the income, please give me the two key. Do we have that one somewhere? Yes. See, for both of them. See, this is for the BMI, and this is for what? This is for mental. See, look at the two key. 1 and 2. Yes, 1 and 2. These are being repeated. Okay. Now you know that how many observations we have. Look at how many observations. 4 choose 2. 4 choose 2. See, you need the 2 at a time. See, you need 2 from 4 observation, 4 groups. You're going to pick 2 groups at a time. 4 choose 2 of this one. 4 choose 2. See, combination. 4 choose 2. If you want, you can use the calculator, but most of the time, what we're going to do, we're going to write the denominator number until that as a product till 1. And we're going to keep the same number of numbers on the top 4 times. It's a product of where they are the consecutive ascending numbers, descending numbers. So see, 6 groups. See, so you have 1 and 2, 1 and 3. I'm sorry, 0 and 1, 0 and 2, 0 and 3, and again 0 and 1, 0 and 2, 0 and 3, and 1 and 0 you don't need it, it's already been done. With the order doesn't matter. 1 and 0, 1 and 2, 1 and 3, then 2 and 3, 3 and then go to 3, 3 and 0 done, 3 and 1 done, 3 and 2 done. Six combinations. 6 combinations. But they were being repeated. Why they've been repeated? Instead of that one, they've been repeated this one, 0, 1 as well. Sorry, 1 and I'm sorry, 1, 0, 2, 0, 3, 0, 2, 1, 3, 1, 3, 2. That's why we have another 6, 12. We don't need, we need only 1, 6. 6 of them. See? 6 of them. See? Go to these numbers. Now go to these numbers and see whether you can reject your H naught. Which H naught? 2 key H naught. See? Now the third H naught. Now. That's a third H naught. 2 key H naught. What's the 2 key H naught? Pair wise pair, that the pair differences, there's no differences between the pairs. There are no differences between the pair. I'm sorry. Here. See this one. See. So here. See this one. That's a 2 key. That's a 2 key. That's a 2 key. It's a 2 key null hypothesis. So we were talking about 3 null hypotheses here. Okay. First one multivariate, second one univariate ANOVA, then third one 2 key. See, it's the third one. But in order to check this one, do we have any 2 key one? Cannot be checked since we don't have a p-values. Are they available p-values here? No, in confidence interval only. Can we use a confidence interval criteria in order to that make a conclusion at the end of the day? Yes, you're gonna see what? You're gonna see this 0 hypothesized value would be inside a confidence interval or not. Whose confidence interval? The confidence interval for mu 0, 1. Let's say 0, 1, whatever that one. See, confidence interval, whether it's gonna contain this one or not. If the confidence interval contain this one, that means you do not reject. If it is outside, you reject. Okay, let's see. Let's go to the everything and say 0 contain or not. Okay, this is the comparison between level 2 and 3, 2, 3. See, 2 and 3. Confidence interval. See, lower bound, upper bound. Lower and upper bound do not contain 0. See, that's 0 outside. That means we reject H0. Significant. This now. Significant. 1 and 3 significant. 0 and 3 significant. See? 0 and 3 significant. 1 and 3 significant. 2 and 3 significant. Then 2 and 3. See, negative. It's been negative to negative. That means it doesn't contain 0. Significant. See, significant. 2 and 0 significant. See, 1 and 3. 1 and 3 already done. 3 and 1. See. So they were done. See, seems like all these significant. All these significant. So on the other hand, see, all these significant. Now what are you going to do? If they were significant, which pair would be the, which variable, which level would contribute at the end of the day? Which group of that, the readings? You have to do this one for separately for both of them. I'm on the mental only. As of now, I'm on that mental one. Under the mental, that variable, I have a 2 key one. See, for the mental one, 2 key. I'm doing the 2 key for mental one. And then under that one, now we see that they were all significant. That means we reject H0. When you reject H0, which pair would be the best pair? Now we have to figure out that one too. We still don't know which pair. Because you did the ANOVA, analysis of variance. Through the analysis of variance, you tackle all at the same time. See? See, all at the same time. You don't know which one is that different from each other. Now you're going to go ahead and do the two at a time. At least two of them are different, but seems like none of them are different. But still, can we figure out which one's going to be the best one? In order to do that one, what I'm going to do, I'm going to go ahead and build up the confidence interval for each and every one separately, one at a time. Okay. Look at what I'm doing. Okay. For in each and every group. Okay. Each and every group, I'm trying to get confidence interval for these levels separately. Look at. I'm trying to build up the thing 0 level and 1 level separately, not together, not for the difference. Individual ones. See, individual ones. Okay.
So then you have to do 6 of those for mental and then 6 of those for BMI.
Yeah. Yeah. See that. I mean, like no, that not 6 of them. Then you're gonna do to this level. See, within the 0 level, see, income. Within the 1 level income, see, they are confidence intervals. See. You see that income. See, that's the confidence interval. That's the their value. See, that's the mean value of the 0 level only. Is the mean value. That's the confidence interval for each level for what? Mental. I'm not talking about the difference. Differences are there are 6 differences, but within that group there are only 4 levels. Since I'm using the t-test and in the hurry that I was using t-test only carry only 2 at a time. So I did this one separately 2. Okay, that's what I did. So if you run like this, I can get my confidence interval for all 4 of them. Individual one. I'm talking about the individual ones. Okay, I'll show you here. Okay, individual one. That's a code for the how to get it. This is the display. See, this is what I need at the end of the day to this comparison. Okay, so gonna see. This is my the first for that level 0 level. This is that mental average. I'm not talking about the difference. I'm talking individual. Its average. These are its confidence interval. Average will be within that. Instead of 3.6684, it's going to be from 3.6567 to 3.68. See, that's a confidence interval. See, I locate that one for 0 level. This is the paired comparison plot. See, look at this is a confidence interval. This is the middle. It is in the middle. In this interval, in middle, you have the point estimate. So interval estimate for mental within the low group, low income group. If it is high, the mid income, that's the average. That's the confidence interval. This is the point estimate. This is the interval estimate. Their mental is a little bit higher when you have a more income. See, you see mentally you stable or something like that. See, something I don't know whatever that we decided. So they then go to 2 groups. See, second group, related to second group. That's the see is the value. It's in the center. This is a confidence interval. It's a third one, third group. I found their confidence interval, not that 2 key confidence interval. These are not 2 key confidence interval. 2 key confidence interval, 2 at a time. 0 and 1, 0 and 2, 0 and 3. That's not what I'm looking for. I did that one. Now again, I have a serious issue. Which one? I don't know. All of them are rejected. Again, I have to go further down. Now I have another issue. You saw the issue. Issue was this one. Issue was that all pairwise comparisons are significant. Then which one would be the best one? We cannot figure out yet. Which group will contribute? Now that at the end of the day, to get the overall differences is the discussion. Then I put over here. Now look at, they were not overlapping. I'm talking about individual ones. They're not overlapping. If you go ahead and look at their values, this may not been drawn to a scale, but they are not overlapping. That means they were significant. Then I'm going to put those numbers like this. Out of those numbers, since there are no any overlapping, you can say the value with the highest one would the best one. See? Within this group, it's like that you're going to compare that to the mental situation within these four groups. The people who are in that third group will have the best the mental situation, or it's other way around, worst or the best. Okay, and then when it's come to the BMI, worst or best based on that now. See, like that. If you're going to compare, let's say that for instance, you're going to compare the salary between male and female, whose salary would be the higher, that like that, whose the mental value is higher, the people in this group or people in this group or people in which group. That's the discussion we are building up. In order to make that conclusion, you have to go all the way down to this level. That's why I'm telling you. It looks like easy, but it's not easy because of systematically you have to get a clear picture. I did several things here. I did the multivariate testing with the aid of the MANOVA table, Wilks lambda. Then that one is significant, H0. I'm mainly focused on H0. When H0 is significant or the reject H0, you move on to the single ANOVA. In a single ANOVA, you didn't stop over there either. Then that one, everything significant. If they were not significant, that your discussions fit over there. See, look at. First you did this one, multivariate one. Then you did this one, univariate one for two variables. Then you did the Tukey, third one, Tukey one, okay, with this 6 comparison. Tukey, third one is the Tukey. See, this one in here, the Tukey. See? Tukey one, you did a Tukey one. See, Tukey can be done in 2 ways. It doesn't matter that everything already included over there. You don't have to worry about that one. You built up the Tukey confidence interval, and with the confidence interval, you decided that whether they were significant or not. Who that you are all the pairwise comparison, pairwise hypothesis. I'm talking about 0 and 1, mu1 minus mu0 minus mu1. Are they significant or not? We found that all are significant because none of this one would contain 0. None of the confidence interval for this, all the 6 pairwise comparison would not contain 0. That means 0. If it is inside, we say confident. If it's outside, we say reject. Reject means significant. We reject this one, significant. Then significant, now we have another issue, which one would produce the best one. Then you go to the individual confidence interval. And then you got the individual, their estimates, and they line up. And then you draw this paired comparison plot. You saw they were not overlapping. See, since they were not overlapping, you decided the one with the highest value would be the best one. Otherwise, that you have to do the comparison among 2 of them again like that. Okay, it's a process. It is a process. Okay, so that's the kind of the discussion built in up over here. Then anything you want to get clear at over here before I move on to the last part of this one? Anything? Anywhere? I want you to that when you write nicely that write it down everything, because the discussion would be the most important part. You can see easily that when it comes to the programming part, programming is a piece of cake. See, look at how many lines. This is not the major part. Major part is theoretical part and the discussion. But in the middle, in order to make that your discussion far easier, that since we are dealing with the massive data, we cannot get it done by hand. That's why we do everything by this program. Let them do and give the results, but we can build up a nice discussion at the end of the day. That's the part very important at the end of the day. Anything not clear anywhere? Here you have 4 groups. That's why you are using ANOVA. Here we have a 2 groups one. I systematically go to 2 group 1 and 3 group 1. And the last part, what I'm trying to do, instead of working with the One factor, I'm trying to go to two factors. See, two factors. I'm going to look at that these two variables with respect to two factors. Each factor has a what? This factor has a 4 levels. This factor has a 2 levels. And their interaction terms come into the picture as well. Dependent variable. Okay, not the independent variable. See, so sorry, this independent variable interaction with the interaction, you can get their mental and BM. These are, see, okay, two factors, two categorical variables. See, that's one. For that one, you can do the sometimes you're gonna do the comparison, predetermined comparison. Predetermined comparisons are called the contrast. That's another setting. Okay, predetermined contrast is another part. You can do Tukey or plan comparison. Look at the plan comparison. Let's say that you have a G groups. Okay, I'm talking about G groups. See, univariate case. Okay, I'm talking about univariate case. Okay, here thinking that you have only one variable, but that particular categorical variable X variable has a G groups. These are called the psi. Psi called the C1 mu1 plus C2 mu2 plus all the way to that group. You're gonna write that on as like a linear combination of all the means. All the means as a linear combination with their coefficients. Under constraint, the sum of the coefficient should be 0. When you pick the constraint, you have to make sure that their summation should be 0. That's why in this example, see, look at the coefficients. -3 plus 1, 1, 1, 1, they sum up to 0. Okay, so that's contrast. And test statistics, if that's the case, it's estimate. I'm going to put the hat to say estimate. If you have a mu become y bar, you know that one. Population mean becomes sample mean. See, very easy. You can see very clearly up to that one. H naught would be what? You're going to see whether there's any linear combination of this mu, any contrast among these means or versus its counterpart. What would be the test statistics? Is the test statistics? That hat should be divided by the mean squared error times summation of Ci squared divided by Ni. And that one, if you square that one, you can easily, sorry, I can put the light. You can easily connected to the F distribution. F distribution with the numerator degrees of freedom 1 and the denominator degrees of freedom n mean summation of all the observation in first group, second group, all the way up to G group. See? Or you can rearrange this one. I'm going to get this part to numerator like that. I can write like that. This whole thing I'm going to call the sum of squares contrast. Sum of squares contrast. See? This is called the sum of squares contrast. SST divided by mean squared error would be because this one is 1 and divided by 1. Actually, this should be divided by 1. But I'm trying to say this whole thing, see, whole thing divided by 1. That's the one that you're gonna see here. Numerator, see, same one. See, this one is nothing but this one you can write SSC divided by summation n minus k. I'm sorry, n minus g. Okay, okay. Now g. See, that's the same thing. See, that's in univariate case. In multivariate case, okay, instead of mu, you have a vector. Now multivariate. This is what we learned. C1 doesn't matter. Vector mean mu is consist of what in our example? We have a mental, we have a what? Mean of mental, mean of BM, mean of mental. The second group is the first group. We have how many groups? 4 groups, 0 group, low income. middle income, excuse me, and upper income, high income. G equals 4, excuse me, and their summation. Contrast, we have taken a certain way that their sum should be 0, and that should be 0 or not. See? And this should be C. Rearrange like one. This is connected to this. And instead of S, you're going to use the pool, the multivariate pool matrix. See this one. See? And that's distributed according to F distribution. See? Connected like this or like this way. Either way. Sometimes. Okay. So let's run this one and see whether we can get those contrast. Okay, I'm asking for see contrast, low versus other income. See, BMI, see, and then I have a 2 variables. Okay, I have a 2 variables. Look at what are the 2 variables. See, 2 factors. See, income and this one. Okay, and if I draw over here, income and gender. See, this one here, this one income. See, this is X1 income here. This one X2, I would say that second factor, gender. So here you have a 0, 1, 2, and 3. Here you have a female and male. Then on this Y, you have a 2 readings. Response variable, one is mental, the other one is BMI. See? When you come to anything, see, any treatment, let's say that you go ahead and look for instance, 1 and 0. See? I'm going to write 1 comma F female. This is called treatment. For that treatment, you have a 2 readings. See? See? 1 for mental, 1 for BMI. So do with all the treatments, all the combinations. So that one. Okay. So this time we're gonna, and then we have an interaction too. Interaction between two factors. Interaction as well. We discussed that one under this theory heavily. If you go ahead and look at the notes, you can see here. Two groups. See? Two-way ANOVA. That's called two-way MANOVA. See? That's for univariate case. Univariate case and its counterpart. And this is the one of the example for that one. The univariate case. See? Water and sunlight. In the univariate case, see? 2 factors. One is that the water, how do you that you put the water? It has 2 levels, daily and then weekly, 2 levels. How the sunlight, these are categorical, because of that one you have to put this in dollar sign. See, low and medium and high, see, three levels. And that's the response variable. See, only one variable, that's a univariate. This guy is determining the univariate, but these two determine 2 factors. Every one, this one has a 2 level, this one has a 3 levels. Okay, 3 groups. That's a kind of example. And then when you come to the multivariate one, called a two-way ANOVA, but two-way G group and B group MANOVA. This side you have a G group, this side you have a B group. So these are the model, and these are that one. And see, that's an example. Look at that. You have a factor, the amount of additive, the other factor, I'm sorry, this one factor 2. Okay, it should be factor 2. Factor 2 changing rate of exclusion. Each one has several variables, not only one variable, several variables, 3 variables you taken into account. See, 3 variables. See, tear resistant, gloss and opacity, you measure 3. See, all these, if you put, it's going to come like this way in a table, if you run. And in addition to that one, you're going to get an interaction term. See, here, look at the interaction term as well. we have interaction term. See, one part is called, see, it says sum of squared cross product, sum of squares and cross product, sum of squares and cross product for interaction, residual, factor 1, factor 2, and total. So you don't have to worry about that one. Then we go to this one. See. See. Then we run that one and see this one. And I'm going to get the contrast as well. Wilks lambda. See, Wilks lambda. By looking at this one, you can say you that you reject H0. See, what is your H0? What H0 that you are interested in? See, you can check either this guy or interaction. Okay, there are 3 of them. Look at. You can run the test flow. See. See. You can do the interaction term. When you get that, see, source of variation for the factor 1, you get like this. Factor 2, you get like this. Interaction, you get like this. Residual, you get the vector. And those are sum of squares. Okay, all sum of squares. Then how could you gonna change? Do this on sum of square, the residual divided by sum of square, the interaction plus this one. From these values, see, they are absolute values. So they are absolute, okay? They are determinant. This vector has that same thing being that this matrix has the same thing being repeated for the lower triangle, okay? You don't have to write the whole thing. It comes like a matrix because we are in 2 dimension now, see? This side and that side for 2 vectors. Sorry, 2 factors. See? So in that eventually you have a several Wilks lambda, see? Wilks lambda for, see, you can build up the Wilks lambda for interaction, Wilks lambda for, sorry, Wilks lambda for, this is corresponding F, Wilks lambda for factor 1, you can build up like this, see? And it's corresponding F, okay? F, sorry, here, F is how they were related. We don't do anything by hand, and Wilks lambda for this one, factor 2, and it's corresponding that one, see? So keep going that one, and see, that not that example. So that's a different example. Okay, let's go to our example here. Then go to results. See. So do you see the Wilks lambda? Okay, let's go to the Wilks lambda. This one, the Wilks lambda for the what? Multivariate analysis. Error that one. Overall. Okay, I'm gonna go further. Okay, let's go here. Start from here. Wilks lambda for income. See, that variable. Wilks lambda for income. See, then you can reject which one? See, you can reject which H0. See, sorry, this one. What is H0? H0 for this one. See, this one. See, the test is rejected. The test is rejected. See, this is the effect from the second group. This is the effect going to be 0, or you can say the averages. Averages are the same. See, averages are the same for this group. See, you're going to talk about this one only, okay? This one only, one at a time. The MANOVA for this side, see, MANOVA for this side will be tested. MANOVA for that one. If you want, you can write with the effect model as an effect model, or you can write that one, see, like this. Let's say that, for instance, if you're interested in factor 1, which is income, okay? How could you gonna write that your H0? H0 you can write mu vector in 0 group, mu vector in first group, mu vector in second group, and mu vector in this one in third group. Okay, Or another way you can write this one, you can write in plain English, or we can write with the vector, or we can write it this way. See, tau 0, tau 1, tau 2, tau 3. Those are the effects one now. See, those are called, see, let's say for instance, example, I'm going to say tau 1 hat is nothing but mu 1 hat minus the overall mean vector. See, that difference is called the effect. See, effect of level 1 of factor 1. Factor 1, which is factor 1 is income. Level 1 is what? Level 1 is high, no, mid income. That factor, you can write like that. Either way is fine. Then you're gonna use what? Wilks lambda for factor 1. And from that one, you use the F from the factor 1. From that one, you use the p-value for factor 1. And p-value less than 0.05, you reject H0, this H0. That's the idea. So everything already here. See, that's why we have so many Wilks lambda. See, p-value, you reject H0. Which H0? I'm talking about, you reject this H0. Their averages are not the same. You are doing their averages coming from their averages of with respect to the income. That group, income groups are not the same. See, like that. If it is not that one, don't do like that. If you want, you can separate and do that one for the same discussion. Go to the univariate, go to the Tukey, go to the again single that confidence interval, that heavy discussion. You can go to this factor at a time. Okay. And if you need the second factor, see, then second factor, you go to this table. See, this one, that's Wilks lambda you're going to utilize. So there you reject that one. Or you go to the interaction. See, you go to the interaction. That's an interaction term too. See, int. See, interaction. See, interaction. See. So that you're going to say that interaction, that if you write that interaction, that, sorry, I'm going to write here. So this factor 2, let's say factor 2, I'm going to write the factor 2, which is BMI. Okay, factor 2, I'm going to write H0. You can say mu naught in this one, mu 1, mu 2, or you can say H0 is, you're going to use what? Beta. Beta hat equals beta 2 equals beta 3, beta 0, beta 1, beta 2, beta 3 equals 0. That's the effect from this is what? This is nothing but, let's say beta 2 hat is nothing but, you go to mu 2 grand mean under what? Under BMI, okay? Under BMI. For the BMI, see, for the BMI grand mean, you're going to subtract from the mu 2 BMI grand, that one. So does with other thing. That one you reject. If you go to the interaction, see, the factor, not the factor, interaction, sorry, interaction term, see, BMI times income. See, that one, we straight go to this one. I'm going to say gamma 1, gamma 0, gamma 2, gamma 3, gamma 4. Sorry, gamma 3. 0, 1, 2, 3. See, go to 0. Gamma stand for what? Effect from the interaction term. That's the effect, not the average. It's the effect. Okay. Under the theory, we discussed that one. Okay. How for, see, we mentioned that one, effect. We sometimes use the average, sometimes use the effect. There are two models. In the very beginning, I mentioned that one. There are two models. One model called the effect model, the other one called the when we come to the ANOVA, I mentioned that one model is effects model, the other one is mean model. Two models we have. Look at the model. Look at the model. See here. See? This is called the means model. You're going to write down your response with the aid of average only, the group average. So you're going to write that one with the average of effect and mean plus the this one. See? Gram mean plus gram mean plus this one would be your reading plus this one. Gram mean plus effect plus that one. That's the one way of writing. If you write this way, you're going to test this guy. If you write this way, your model, you test this one. If you have several levels, you're going to say mu1, mu2, mu3, mu4. Okay? If you have this one, you're going to check this one. This is the one being checked. This is the one being checked. All the levels would carry the same average. Or do that? Do they do all of that? The levels carry the same effect. If you put the effect, you put the zero. There's no effect. See? That's why we built up these pieces. See? Equivalently, either you're going to write this way or this way. That's the same thing I wrote. That's for the one way. One way you have only one effect, and the other effect you denoted by beta. That one you have a two-way ANOVA. See? Yeah. Sorry. Yeah. This one, beta separate interaction term given by gamma. So your model would be any reading. See, your model would be this one. This is the important part. See, if you read any reading, the first group and second group, go to this treatment and go to the reading. See, I go to the ith one, then I go to the jth one from the second group and go to the kth reading. It is same as the average of the first factor plus the average of the second factor plus the average of the interaction term plus the average of the error is same as grand mean plus effect from the first group. See? And effect from the second group, effect from the interaction plus this one. What do you test at the end of the day? Either this guy and for all the levels, or this guy for all the levels, or this guy for all the levels, or this guy for all the levels, this guy for all the levels, and this guy for all the levels. That's what we were writing over here. See? You use this one, either this way or this way. For the interaction, you straight go to the gamma. For the first factor, you go to the beta and tau. You don't use alpha. Alpha will be mixed up with the level of significance. And can you reject? Do you have a necessary that information to reject that? Yes. For that one, I want you to just to do the reject H0 or not like that. If you write that one, that's more than enough. And plus, looking into the contrast. Can you check the contrast? Where's the contrast? Now we talk about the contrast as well. I am building up a contrast. What is according to the contrast? Okay. Okay. Let's say that there's the contrast part. Looking for the contrast. Mass index should be somewhere. Contrast. Do you see that? No. This is for the interaction term. This is for the interaction. Oh, sorry, this is a contrast. I'm sorry, I'm at the right place. See, okay, contrast. See, percentages. PMI, PF, this characteristics vector. So this one. See, this for the contrast. See, Wilks lambda for contrast. P value. See, that means I'm writing a. I'm testing what? I'm testing a predetermined that pre-plan comparison, not between two, between all, not mu1 like that. See, not mu1 equals to mu2 equals to mu3. I'm going to go to the linear combination. See, psi. See, look at the psi. Psi is what? C1, C1 mu1 plus C2 mu2 plus C0. I'm going to say 0, C0, C1 mu1 plus C2 mu2 plus C3 mu3. On the other hand, we have selected the mu3 plus 1 time mu1 plus 1 time mu2 plus 1 time mu3. See, that's my H0 equals to 0. Where C1 plus C2 plus C3, C0, I'm sorry, C0, C1, C2, C3, negative 3, plus 1, plus 1, plus 1 equal to C. Satisfy the constraint. Constraint is satisfied. See, constraint has been satisfied. How do you check that? I'm looking into the p value. Look to the p value. Wilks p value. Wilks p value for contrast. And it is less than 0.05. Reject that one. That contrast you cannot take into account. That's a very interesting thing that like sometimes the sales coming from a certain two stores, their average will be compared with another two stores from another city like that. Those are heavily utilized in practical application. This kind of a contrast very heavy. So let's say that average income coming sales coming from like a two stores, like a let's say a certain Walmart or something like that. They have a two stores in a certain region and another region they want to compare, but at the same time that region they have a two stores, so three stores. They're gonna get the average of that one. That means C1 like that average has been multiplied. Some has like a 3 times more than the sales of the first one like that. That's kind of a discussion. And divided by 2 will be compared. See, like this. See, 3 times mu1 plus mu2. See, the average will be compared from another region. See, like that. But at the end of the day, when you get everything to one side, okay, everything to one side, they should the coefficient should add to 1. The comparison should be done like that. See, H0 you're gonna write like this way. See, if you have a 2 of them, see here you have a 3 or 4 of them. See, this will be compared with the, let's say that the 2/3. This is 1 2/3 plus 1/2. This should be 4/2. Then I can say mu3 plus mu4. See, so 3/2 mu1 plus 1/2 mu2 minus mu3 minus mu4 equals 0. That's your H0. See, then 2/3 2. See, and this is the one that this is your psi. Psi is 3/2. That's psi. This is psi equals 0. Where summation of CII goes from 1 to 4, which is 3/2 plus 1/2 minus 1 equals 0. Like that, that kind of a not related to this one, okay, not related. I was talking about that. We're going to compare. There are some sales of these two stores will be compared with the average from the weighted average from the other two, like that. If you want to do that comparison, you built up the contrast. You have done that one, but that one you did for related to one variable. Let's say we do that one for more than one variable. See, vector form. See, that's the interesting part. You're gonna looking into not only sales. See, not only sales. Some other factor will be that, sorry, other variable you can take into account too at the same time. Like a sales plus that revenues or whatever that 2, 3 things at the same time. That's how you're going to build up. But in our case, it's easy that you go to the something, contrast the wilks, and based on that one, you make a conclusion and write a nice report. And that those three enough for this class. But it's a very, very heavy, broad field. This one, the multivariate is a that's it's like a monster. You don't want to go all of them. That's why I narrow down to that very clearly three models. That's enough. Okay, that's enough to that one. You do like that for if you want, you can keep the same variables, or you pick your own variables, build up like a nicer something very practical, something makes sense. In that way, you can come up with that. See, even here, see, for the income, I'm asking for that one contrast only for the income. Only for the income. If you want, can you ask for the gender as well? Yes, you can ask for that one too, but contrast, you have to give like this. Look at it, all the codes, look at the results, look at the theory, combine. But I know this is a very, very intensive because within a short period of time. But doesn't matter that just write it down something and nicely write the codes and then turn into me whatever that you feel like that the best way to that present that. But don't go beyond this one. I don't want to go beyond this one. It's getting heavy. Simply go this one, simply go this one, simply go this one. Okay. Anything you want to discuss that on this one? But even in next Monday, if you have any question on this one, I can go through that one again and then have a look at it. Or what I'm gonna do that I sometimes that I prepare some nicely that all the answers and then I can upload, you can have a look at it and then get an idea. I want you to learn this stuff mainly rather than you being tested. I'm not the one to test you. You will be tested when you go outside to the society, okay? So mainly what I'm trying to do is here, I want to try to build up a good knowledge for that beneficial for you to that to move forward in the, down the road in the future. Anything, something, anything that you miss something you want to discuss, don't worry about that anything on these notes. You don't have to worry. Those are like a guide only. You don't have to worry about these numbers and these letters and anything. Just pick that example. Run this kind of example too. You can run that one too. See? Whatever, if you need anything, any codes, any data, anything, just let me know that. The theory part, you don't have to worry about anything. All theory already embedded over here. You don't have to go and look for anywhere. It's already there. And graphical format we discussed, theoretical, broader discussion. It's intensive because within this material we normally cover within 15 weeks. It's that much of material. But you guys are taking that challenge and then take classes like this, very good. But we have more example to see. We have more example on this one. See? So this example. Example for see. That's a 2 way now. Another example. See? Same thing that instead of that uploading data, they see you're gonna do the data over here and then get this one. Pretty much the same thing. See? That's what this is something related to that too. Homework, this code, I think I have already given, if anything being used. Okay. Okay, if you guys don't have any question, then I'm gonna let you go that, and you guys have a great weekend, and then enjoy your weekend, and see you on Monday. Stay safe and be well. Okay, take care.
Yes, Thank you.
Thank you very much. Okay, take care.
Right.
Thank you. Bye. Take care.